Look up at the night sky. Billions of stars, countless galaxies, stretching across unimaginable distances. For centuries, humanity has gazed upon this cosmic ocean and asked a fundamental question. Are we alone? Is Earth the only oasis of life? In this vast, silent universe? Welcome, space explorers, to our deep dive into the epic search for extraterrestrial life. So, what exactly are we searching for? Defining life itself is tricky. On Earth, it's based on carbon chemistry and liquid. Water. But could life elsewhere be fundamentally different? For now, scientists often focus on life as we know it. This means looking for environments with key ingredients: liquid water, essential chemical elements like carbon, hydrogen, nitrogen, oxygen, and an energy source. This leads us to the concept of the habitable zone, or the Goldilocks zone. Around a star, the region where temperatures are just right for liquid water to exist on a planet's surface. Not too hot, not too cold, but just right. But even on Earth, life thrives in extreme conditions. Think of microbes in volcanic vents or under Antarctic ice. These extremophiles expand our understanding of where life could potentially exist. Our search begins close to home, within our own solar system. Mars is a prime candidate. Evidence suggests it once had liquid water on its surface, rivers, lakes, maybe even oceans. Rovers like Curiosity and Perseverance are actively searching for signs of past, or even present, microbial life beneath the Martian soil. They analyze rocks, look for organic molecules, and study the planet's geology and climate history. But Mars isn't the only place. Jupiter's moon Europa and Saturn's moon Enceladus are incredibly exciting. Beneath their icy shells, scientists believe vast, salty subsurface oceans exist, warmed by tidal forces. Even spews plumes of water vapor and ice particles into space, containing organic molecules, tantalizing hints of a potentially habitable environment hidden below. Future missions aim to explore these ocean worlds more closely, perhaps even drilling through the ice. Saturn's largest moon, Titan, with its thick atmosphere and lakes of liquid methane, also presents a unique, albeit very different, potential habitat. But our solar system is just one among billions. The real treasure trove might lie far beyond, orbiting other stars. These are the exoplanets. Thanks to missions like Kepler and transiting exoplanet survey satellite, we've discovered thousands of them. These telescopes often use the transit method, detecting the tiny dip in a star's light as a planet passes in front of it. The next giant leap is analyzing the atmospheres of these distant worlds. This is where the incredible James Webb Space Telescope comes in. By capturing the starlight filtering through an exoplanet's atmosphere, James Webb Space Telescope can detect the chemical fingerprints of different gases. What are we looking for? Biosignatures, gases like oxygen, methane, or others in combinations that are hard to explain without the presence of life. Finding a strong biosignature in an exoplanet's atmosphere would be a monumental discovery, arguably the biggest in human history. Beyond searching for microbial life, there's another, perhaps more ambitious quest: the search for extraterrestrial intelligence, or SETI. This involves listening for signals that couldn't be produced naturally, potential broadcasts from advanced alien civilizations. Giant radio telescopes scan the skies, hoping to pick up narrow-band signals or complex patterns that might indicate technology. We're also starting to look for techno-signatures, other signs of advanced technology like laser pulses, massive artificial structures, think Dyson spheres, though highly speculative, or even atmospheric pollution. On an industrial scale, SETI is a long shot, a search for a needle in a cosmic haystack, but the potential payoff, confirming intelligent life elsewhere, is immeasurable. So, where are the most promising places to look right now? Within our solar system, Mars, Europa, and Enceladus remain top contenders. Beyond, we found several potentially habitable exoplanets. The TRAPPIST-1 system, with multiple Earth-sized planets in the habitable zone of its cool dwarf star, is fascinating. Proxima Centauri, orbiting the closest star to our Sun, is another tantalizing target, although its star's frequent flares might pose a challenge for life. The list of potential candidates grows with every new discovery. Let's pause and consider the implications. What if we do find life? If it's simple microbial life, it would still be revolutionary. It would tell us that life is not unique to Earth, that the universe is likely teeming with it. Biology would become a truly universal science. But what if we find intelligent life, or detect their signals? The impact on human society, philosophy, religion, and our understanding of our place in the cosmos would be staggering. It could unite humanity or cause widespread panic. How would we respond? Should we respond? This brings us to the famous Fermi paradox, first posed by physicist Enrico Fermi. If the universe is so vast and old, and the potential for life seems high, why haven't we found any clear evidence of advanced alien civilizations? Where is everybody? There are many proposed solutions. Perhaps life is incredibly rare. Perhaps intelligent life inevitably destroys itself. Perhaps advanced civilizations exist but choose not to contact us, the zoo hypothesis. Or maybe there's a great filter, a hurdle that's extremely difficult for life to overcome, whether it's the origin of life itself, the jump to complex intelligence, or surviving long-term technological advancement. Is that filter behind us, or ominously still ahead? The search for extraterrestrial life is more than just science. It's a reflection of our innate human curiosity, our desire to understand our origins and our destiny. We're using increasingly sophisticated tools to scan the skies and explore distant worlds. We're analyzing light from stars trillions of miles away, sifting through data for faint signals, and sending robotic emissaries to our planetary neighbors. Whether we find simple microbes on Mars, hidden oceans on icy moons, or signals from a distant intelligence, the quest itself pushes the boundaries of our knowledge and technology. We don't know if we'll find an answer in our lifetimes, but the search continues. Because knowing whether we are alone is perhaps the most profound question we can ask. Thanks for joining us on this cosmic quest. What do you think? Are we alone? Let us know in the comments below. And don't forget to subscribe for more journeys into the wonders of space and science. Until next time, keep looking up.